Dear students, in the last class we have seen that interference and the conditions for interference, then we have seen the interference on thin film. So, in this class we are going to see about what is polarization and what are the different types of polarization and how to achieve the planned polarized light in different properties by using the reflection, transmission and scattering. You can obtain some pan polarized light. So, what is polarization? So, polarization is nothing but converting unpolarized light into polarized light. So, here what is unpolarized light? Generally the light which is emitting from the natural source, from sun, stars, whatever it may be, the light waves is vibrating in more than one plane. So, it is vibrating in more than one plane. So, that is called unpolarized light. So, this is a natural light which is emitting from sun and other things is a unpolarized. So, light emitted by the sun, lamp in a classroom or by candle flame is an unpolarized light. So, it is possible to transform this unpolarized light into polarized light. So, this process generally called as a unpolarized into polarized light is known as a polarization. So, there are many types of process of converting unpolarized into polarized light is there. So, this is that some types are there: polarization by transmission, polarization by reflection, polarization by refraction and polarization by scattering. We can convert unpolarized light into planned polarized light. So, some other types also there. Whatever we are considering is a planned polarized light. Okay. So, some other circularly similarly elliptically polarized light also is there, but we are going to see only the planned polarized light. This can be achieved by transmission, reflection, refraction and that scattering. So, polarization by transmission. So, in general that unpolarized light is represented by this, like the graphical representation we can see this like this. So, this is the unpolarized light. So, this can be converted into planned polarization by transmission, by transmitting through certain crystals, say for example quartz crystal. So, here we are having that axis, this is called optic axis, or transmission axis. So, polarization by transmission. So, here the unpolarized light is converted to transmit by transmitting through certain crystal. This crystal is called quartz. So, through this optical axis or transmission axis, when you pass through this, it converted into planned polarized light. So, this vibration is any direction. So, when pass through this along this, only it will allow these vibrations along parallel to this transmission axis or optic axis. So, we are having only this type of vibrations here. Okay. So, this is light. Basically, so we are using this quartz crystal, some of the crystals which have this type of property by transferring the unpolarized light to polarized light. So, we are having these crystals which generally we called polarizer. So, because it is converting the unpolarized light to polarized light. Similarly, here also crystals which is here same crystals of polarizer, same thing, but we are generally we are telling this one is a analyzer. What is the difference between this polarizer and analyzer? So, polarizer is nothing but it is any device, it is any device that can convert white light means what? That unpolarized light into plane polarized light. So, analyzer, what is analyzer? Analyzer is a device used to determine white light, determine whether the light is polarized or not. How can you use this analyzer? Because if when you rotate this analyzer, what you will see here. So, the intensity is varying from 0 to maximum, because whenever the intensity is maximum, only this axis, the transmission axis parallel to this polarized. Otherwise, if it is crossed, you will get the intensity will be 0. So, that is why we call this analyzer is used to determine the whether light is polarized or not. Suppose if you rotate this continuously, you will not, there is no change in intensity, that means that coming light is unpolarized. And for example, here if you rotate this polarized light, the intensity is not changing anything, that means it has the unpolarized light. So, it is polarized light, then only you will get when you are rotating the intensity will 0, maximum and 0, varying between maximum and 0. So, then next we are going to see the Knowles law. So, it will tell you that actually this law, according to this law, the intensity of the polarized light coming from analyzer is proportional to the square of cosine of angle between polarizer and analyzer, that is intensity is I is equal to I naught cos square theta, that is intensity is directly cos square theta. In terms of optionally we get the I naught cos square theta. Suppose for example, here we are having this is polarizer. Okay. So, this is unpolarized light of intensity is coming. So, here after this the intensity is reduced to I naught. Okay, so this is the transmission axis. So now we are keeping that um, so this angle between these is, for say for example, so this is the transmission axis, but this transmission axis here of this analyzer is have an angle with respect to this transmission axis is 40 degree, right? Suppose we are saying 40 degree. So the intensity of the polarized light coming from the analyzer is proportional square of the quotient of angle between polarizer and so you can see that angle of the transmission axis is 0. So here you can see this, it is having angle with 40. So the angle between polarizer and analyzer here it is 40 degree. Okay, so now here what is the intensity here? I2. So we can see that after coming from the polarizer, the intensity is half of that one, that is I1 is equal to I naught by 2. So this is the I naught, intensity of unpolarized light. So I naught, intensity of unpolarized light. So I1 is intensity of plane polarized light from the analyzer. Okay, so I2 is intensity of light plane polarized after coming from the analyzer 2. Okay, this is analyzer 1, this is analyzer 2, or you can say the polarizer also. Okay, so suppose for example 50 or 100 watts per meter square intensity is incident on this analyzer. We are having the intensity I1 is equal to how much after coming from this polarizer is 100 by 2, that is 50. So, we will give you 50 watt per meter square. Okay, what is here? What is the intensity here? I2 is how much? So, I2 is, you have to use this formula, I2 is equal to I1 of cos square theta. Okay, so here the intensity coming here is I1, right? So you have to substitute here. I1 is, you can substitute, what you will get, I1 is 50 cos square 40 degree. Okay, so you have to understand the I2 is nothing but the intensity depends upon this incident. So here the incident intensity in terms of I0 you get to I1 is equal to I0 by 2, that is 50. So I have to substitute here. So you will get I2 is equal to 29.3 watt per meter square. Okay, so this is the polarization by how the intensity varies and how the polarization plane polarized light converting, we are in converting through transmission. Next we are going to see polarization by reflection. So whenever unpolarized undergo so unpolarized light can undergo polarization by reflection of an on non-metallic surfaces. See for example here this is a water surface which is non-metallic. So the light radiation from sun, so incident here, so it has unpolarized light, So after reflecting from this surface, it is converting into polarized, which is parallel to the surface. So polarized light, this one is polarized light. Polarized light parallel to the surface. So it's completely, it is a non-metallic surface, right? So unpolarized light can undergo polarization by reflection of a non-metallic surface. It goes to the, it creates the polarized light. That polarized light is parallel to the surface of the material. So it is water surface or snow field, whatever it may be, it will get unpolarized. So it depends upon the angle. So that angle is called Brewster angle. So Brewster angle. So it is nothing but the angle at which the reflected light is completely plane polarized. So the angle at which the reflector is completely polarized is called Brewster angle. It is given by in terms of tan, and tan theta p is equal to n2 by n1. So this is the refractive index of medium 2 and refractive index of medium 1. So this is the refractive index of medium 2. This is refractive index of medium 1. So rarer medium, right? Denser medium and rarer medium.